Good morning. I'm talking quiet because it is 3:13 in the morning and I'm going to travel down to Southend-on-Sea where Kranzle UK is, so feeling a little bit tired, but vamos. This is by far the best time of day to drive. There is absolutely nothing on the road apart from probably a couple of wagons. Have they seriously closed the road off? I can't even get down the M6.
At least we don't need to.
Well, that's just added a few bits to it.
It's upside down? 10 minutes in, Dad. we're already eating.
Snacks are the worst thing on the way down.
I don't know whether it got it, but the M56 is closed.
So just passing the Trafford Centre because of the diversion, we got the M56 that's closed, and I don't know which junction that is. So I'm going to take another diversion, a rat route round. Every set of traffic lights.
It's fine.
Every diversion.
It's fine. Yeah!
Vamos!
Vamos!
So now I've done 31.5 miles. And I'm exactly where we started off in Warrington. That's not funny. Finally.
Is this the M6?
This is the M6.
Finally. Progress is hopefully going to be made from now on.
Why is it waggling?
And off we go! No.
Head southwest
Oh well,
towards
we can
M1.
stop for a second anyway.
Stretch our legs, have a pee.
Yes.
Dinner time.
Well, it's not even dinner.
Breakfast time.
My stomach just rumbled. Well,
Well, what?
we got 10 minutes?
10 minutes to go.
Finally.
Fine.
How long have we been in the car?
Since
3:30. It is now 9:30.
oh,
6 hours. 6 hours. That is tragic.
so we made it to Kranzle after a 6-hour trek, and it's here.
So with all the chat in the background about whose car's better and whose is quickest, I decided to do a bit of a voiceover. Today we went down to Kranzle, Southend, to see the E-Therm. Now there's 4 different versions of the E-Therm depending on what power supply that you have, but it is an electrically heated hot pressure washer. Now it does need a 3-phase power supply. The smallest one needs a 32 amp. And the biggest is 125 amp power supply, and that plug is huge if you have to plug it in. Now these are mainly for big sites, big chemical sites maybe, or pharmaceutical sites. Or anybody who has a 3-phase supply usually will have like a 100 amp breaker in there, which you'll be able to put a 63 amp socket, which you can get the good machines in there. There is the 125 amp, that's a little bit more specialist. You probably see that in, like I say, the big chemical factories. There's people who really have the power, who have the big motors to run all the equipment they have on site. So starting with the technical data on some of them, the 500M18, 130 bar, it's 8 litres a minute. The motor is pretty much they're very similar to a good single phase machine. So when you get a let's say a 2160, 1152, that sort of thing, it's almost the same pressure as that, which is ample for most people, and then the heat will come onto it. So that one's a 29 amp, so you're going to need a 32 amp socket, which most 3-phase, a lot of them, they won't put just a 16 amp socket in there and a 60 amp supply. They'll always go to the 32, which is the sort of next one up. The power cable's a 5-meter power cable, 32 amp supply. It's literally about 1 meter by 800 by 1 meter, so it'll almost fit on, say a Euro pallet size by about 1 meter tall. 128 kilos, so it's a lot lighter than a diesel powered machine, so a diesel fired boiler. And it will deliver the hot water up to 48 degrees above the ambient temperature on that 500. Now that's the sort of 18 kilowatt if you want. There is a 500M 24 kilowatt, which is pretty much the same machine, but this one will have a header tank in there. So where the 18 would draw straight from the water supply, so you'd be able to run it off a tank or anything like that, the 24 will have a header tank in there, so the water would fill the header tank, the machine would suck it out of the tank. So if you needed to run it off a supply, then you would have to do some little bits of unscrewing a pipe and putting that on there. But it's very, very straightforward, very simple to do on these. This one's, the power intake is classed as a 27 kilowatt, but with the motor and all the rest of it, then they advise to put a 64 amp supply in there. So once you get the 64 amp supply in, you'll be able to run that machine, and it is virtually the same machine, apart from the header tank, obviously, same 5-meter extension cable, 128 kilograms. So there's not much weight difference between each one, but it will heat up quicker and it'll heat up hotter, so it'll go to the 60 degrees. Moving on from there is the 603M36, where the 36 kilowatt again is a 64 amp system. So it's saying a 38 kilowatt, so putting a 64 amp breaker in there and a socket, you'll be able to run this machine. And this is probably the machine that I would go for. 603 36, it's 150 bars, so it's more pressure, 10 litres a minute, where if you know anything, instead of 8 litres, 10 litres, you've got another 2 litres per minute. Every litre per minute is worth around about 10 bars. So if you can imagine, this is already 20 bar over, you've got another 20 bar on top just with the litres per minute as the way it'll feel. So again, 400 rev motor. This is going to feel like a bigger cold water machine, 240 volts, but it'll be ample to do absolutely everything. 5-meter cable, same again. The footprint is virtually identical. You've got a little bit taller where it'll with the boiler in there, so the cabinet's a little bit taller the way it looks, as 1450, so almost 1.5 meters. It is a lot heavier, 160 kilograms, but it is nowhere near the weight of a heavy steel coil on a diesel hot powered pressure washer. This one will get up to 80 degrees C, and it will get there very, very quickly. I'll show you that a little bit later on. The fourth and the final one in there is the biggest machine that they do, the 87348. So I'm going to say 48, almost 48 kilowatts as the boiler. My dog's just about to walk off and tippy tap, so I'll wait till he goes. And he's gone. Where was I? So yeah, the power intake, 52 kilowatts. So when you get the 52 kilowatts, you're going to need that big power supply. So it's classed as 125 amp breakers in there. So you're going to need the bigger size plug. Everything's going to be bigger. Most small industrial units or anywhere like that will probably not be able to get this done without having a lot of expense from the electric company to change the fuses. But places like the chemical factories and the big ICI type of plants and the pharmaceutical plants that use this all the time, they will have that power supply, so it'd be next to nothing for them. They'll be able to hardwire it into a big breaking box and they'll have done no problems. That is the same exact dimensions as the 60336. It's just got that heavier boiler, and that heavier boiler will get up to 80 degrees C, 150 bar at 13 litres a minute, so it's even more of a pressure. So you get a lot more litres per minute, a lot more pressure, and the heat will be the same as that. So they do use different size lance nozzles. Obviously that's created by the flow of pressure, the flow of water and the pressure of the machine. So you've got 03, 035 and 05 as the nozzles. On the 3 higher machines, there is an eco setting, so it'll do half the kilowatts. So you switch the switch across, and instead of it being, say, the 36 kilowatt, it will run at 18 kilowatts, which will still get the ample temperature. We did a couple of tests on there where it'll get slightly less heat, but it's still hot enough where you can't hold the lance properly. So it's more than ample. If you had an eco setting on the a normal diesel fired hot boiler, hot pressure washer, then it would be the same as that. You know, we're cutting out in and out 50, 60 degrees or whatever it is, where it'd be ample to clean anything like cars, and most applications you don't need it hotter than that. We've done a lot of tests. We did a lot of tests today where as you're running the pressure washer, obviously the flow of water going through is cold water going to the hot water, same as a diesel fired boiler. And there's a way of keeping it temperature right really gently in the middle, a really sweet spot. So if you've set it at, say, 50 degrees, it'll go 50, and then the boiler will cut out and it'll just get to about 51, 52, and then slowly go back to 48, 49, and keep within that sort of tolerance. Most hot pressure washers, when you get the diesel fired boiler, you'll turn it on, it'll get to a temperature, and then it will shut the thermostat off at the outlet, and it'll be that hot inside the boiler that the temperature will rise, say 10, 15, 20 degrees above it even sometimes, and then start cooling all the way down. And once it gets past, and it'll go almost cold before it starts kicking in again to keep that temperature. So there's a really wide fluctuation of the temperature from when the thermostat cuts it in and out. The Kranzle machines there, they have like the boiler to you can almost set it to, say, sort of burn 100% if you want. So have the boiler on 100% of the time, or you can knock it to, say, 80% or 70% of the time, and that will keep that 70% time really narrow, so your temperature is constant. It's going to only fluctuate a few degrees either side while it cuts in and out and cools down and heats up. You can obviously put it on the other setting where it'll get to 80 degrees, cut out at 80 degrees, and it'll obviously stay hot for a little bit and slowly increase. And then when it starts cooling down and it gets past there, it'll start the boiler up again and it'll go back, and so on. I'm probably doing that a little bit wrong for the camera. I might have to switch that around. So yeah, so it'll heat up, and then when it cools down, it'll cool down to about here before it actually catches up with itself and gets to 80 degrees again in temperature. We did also we tried to turn the pressure down to get it as hot as we possibly could, and it just got to about 100 degrees and the safety thermostat cut out, which is exactly what it's meant to do. All you have to do there is turn it off, turn it on again, and it'll be working perfectly again from there. But electrically heated machine, 100 degrees maximum when you're reducing the pressure before it cuts out is almost unheard of. Every other electrically heated machine that I've certainly seen, it works like a kettle. So all the water will go into a big tank, and in that tank you will have water fed in, cold water fed in, and there'll be an element at the bottom of that tank, and it'll be all insulated if they've got any sense. And the element will heat the water up. So when the water gets to a certain temperature, which could take, bearing in mind that there'll be sort of 20, 30, 40 litres in this tank, it's going to take a while for it to heat up. So it's not going to be instant like the Kranzle one. The Kranzle just instantly heats up. In fact, it will get hotter quicker from a cold start than a diesel-fired boiler. So you're going to be sort of saving. We go through all the savings afterwards. The other styles, like I was saying, was the kettle, where the heating element will heat the water up, and then from that hot water, the pump then will suck that warm water through the pump and then out to the lance and gun. So there's a couple of design faults, if you want. So the pump needs to be rated for hot water. You're going to suck warm water through, so it's going to soften the seals, it's going to do all that sort of stuff. You've got the waste of electricity, where it's just got to sit there heating up all the time, and it's constantly on, so your electricity is going to be just ticking over all the time. And then the temperature fluctuations. Obviously, once your temperature is really hot and you start using it, once the level drops, the cold water is being added and it's going cold virtually instantly. And then it's going to take a while for it to heat up so you can get proper temperature. The way the Kranzle works, it's almost like a combi boiler. So you will have the pump, you will run the pump will run cold water through it, so it's exactly the same using a cold water pressure washer, and then it will hit the boiler. Once it hits the boiler, it starts instantly heating from that boiler all the way through the elements and then out. And that's efficient enough to, at full pressure, to get right up to sort of the 48, 60, 80 degrees, whichever one it is, running full temperature within a matter of seconds. I do have a video, I'll probably play it now, where there's a difference between the diesel-fired boiler and the electric boiler, and the heat and the temperature and the way that it goes up. So with the hot water, diesel-powered hot water on the left and the electrically heated on the right, 5 seconds in and it's already at 55 degrees. 10 seconds in, it's already at 60. It's going up to 70. 15 seconds and it's red hot now. So 80 degrees there, you'll not be able to touch it. Whereas the diesel-fired boiler on the other side, it's still going. It's 50 degrees. It's still warm, 25 seconds. It's not too bad. But it's 60 degrees, 30 seconds at 60 degrees. It's almost half the time. 35 seconds, this is almost 90 degrees. So it must have been a warm day when they did this test, where the ambient temperature of the water is sort of warm as it goes in. So if it's sort of 20 degrees water outside in the pipes coming in, then obviously it's going to be hotter going through because it's warming that little bit quicker. If you say use it in the winter and it's like 2 degrees, almost freezing water, then of course you're going to have that little bit of a difference where you're going to get that temperature range. If it's warm water coming in, it's going to be hotter coming out. If it's colder, it's going to be colder coming out. But it'll still, they did that. It was about a minute long to get to 90 degrees. There's nothing else like it. If you had a kettle type of machine, it would run. You heat it up to sort of 80 degrees. You would use it for 5-10 minutes, and it'll be down to 30 degrees, and it'll stay at around about 30 degrees until you let go of the trigger, let it fill up, let it heat up, and then start again. So on to the test report and a little bit of a comparison. We did this test 9th of the 11th, 2022. 9th 9th of November. The water inlet temperature, so the ambient temperature of the water, was 17 degrees. We tried the Therm 635, so the conventional diesel powered hot water machine. It runs 130 bar, 10 litres a minute, 230 volts, 15 amp machine approx. The time taken to get to 40 degrees was just 28 seconds. The time taken to get to 60 degrees was 40 seconds. And the time getting to 80 degrees is 62 seconds, with a maximum temperature that it would run on full pressure as 90 degrees, which is pretty hot. We tried then the eTherm 603-36, which is the 36 kilowatt version of the eTherm. So obviously 3-phase, 55 amps, so you're going to need the 63 or 64 amp plug. 150 bar at 10 litres a minute, which is beats any sort of cold water 240 volt machine, to be fair. Time taken to get to 40 degrees was 14 seconds. The time taken to get to 60 degrees was 21 seconds. And then the time taken to get to 80 degrees was 50 seconds. The maximum temperature on full pressure, full heat, was 82 degrees. And the maximum temperature on the eco setting, if you remember the little switch on the front, was 48 degrees. Then we tried the eTherm 873. This was the 48 kilowatt one with the big plug. You'd have to have the 125 amps or plug or system on there. It runs 150 bar at 13 litres a minute, so it's much more litres per minute on there. The time taken to 40 degrees was just 10 seconds. And then the time taken to get to 60 degrees was 15 seconds. And then the maximum temperature on full pressure was 78 degrees. So it didn't get above 78 degrees. On the eco setting, the switch on the front was 45 degrees on full pressure. So that's the maximum temperatures on there. So I hope that sort of explains a little bit of how quick this boiler can heat water up. So heating the water with electricity, like these eTherms, is much more efficient than the diesel fired boilers. It's so much cleaner. There's no exhaust gases, so you could keep this indoors. You know, if you had a food factory, you wouldn't be able to burn diesel inside. You could put it indoors, no problem, in the corner of the workshop or whatever, and you're not going to gas your engineers out. You're not going to gas anybody who's using the machine with CO2. It does work out a lot cheaper to run than having diesel fired machines. So you can't use red diesel anymore in the UK. Road diesel, normal white diesel would go in it. You would have to obviously get somebody to get the diesel, to store the diesel, making sure that it doesn't spill the diesel, to make it quite efficient. Whereas there's none of that. You just plug it in and use it as a hot water pressure washer. Servicing costs on this machine is much lower than a diesel fired boiler. So you're literally only servicing a cold water pressure washer. When you get a diesel fired boiler, you've got the HT leads, the electrodes, the burn nozzle, the fuel filters, things to go wrong if they put dirty diesel in it, things like that. Whereas the electrically heated machine is literally just servicing a cold water pressure washer and then an electric check. So more of an upfront cost for the machine, but a lower running costs. All the prices will be on the website for all the machines. The diesel fired machine, 240 volts, and the difference between that and the electrically heated machine is around about £900. So if you budget in a grand difference, that's what you're going to be looking at.
So, where are you off to now?
Home, hopefully.
Down for an extra day.
No, home tonight.
All the way to Warrington.
All the way to Warrington.
So I am nearly home. The lighting has completely gone again. It is nearly 8 o'clock. I've done nearly 500 miles today. It's 484, but it'll be about 500 miles by the time I get home. I've still got a quarter of a tank of fuel left in this Citroen DS3, which is pretty good considering we've been leathering it down the motorway. There's loads of accidents and it's been quite an eventful trip. So I just want to thank everybody at Kranzle. We've got Graham, Ben, Will, his technical master. We've got Ken, Malcolm, Dan, all the people at Kranzle make me feel so much welcome. I'd like to thank Kelsey for keeping me awake with some banging tunes all the way home. I am going to go straight to bed. So if anybody's interested in a electrically heated machine, a sort of unique machine on the market, really, to be fair, I hope this video was quite informative. If you have any questions, leave them in the comments. If you have an inquiry for them, contact Aquaspray. Fuel has gone up like 10 pence since I filled this up the other day. Anyway, let's see how much it costs. It is 193.9.
£69.01 for 35.59 litres. Oh yeah.
So we did 491 mile. I've just filled it up for 35.59 litres, so nearly 36 litres, and it's cost £69 and a penny.
Yeah.
So you can do the maths and let me know in the comments.
Bearing in mind it's gone up 10p in the last couple of days, which is fun.
It was
81 the other day, because that's when I
was 81 down there this morning.
Well, not anymore.
No, not anymore. Do you do this driving around?
Oh, yeah. And now we've got to take a detour because this entire road's closed.
Another detour. Ah, we can't even get down this one.
What if we just use all the fuel already and then it's just an endless cycle?